with the lectures and call on the stage Bogdan Kecman for Oracle. Please give him a round of applause.
Hello. I'm Bogdan Kecman. Work in Oracle for, I think, like 11, 12 years, something like that. Using MySQL since it exists. Work this sort of stuff for 30 plus years, so most of you already know me, saw me somewhere, read something I did or wrote. But since I do work for Oracle, I need to go through this slide, and this is basically anything I say in my name, not theirs. They are not responsible for anything I do or say or get drunk or promise or whatever. So taking that out of the way, let's talk about today's presentation. One thing, I don't see any kids here, but I learned my English watching American movies, so I tend to swear, so I apologize in advance. We're today going to talk about advanced databasing, but I cannot teach you how to do advanced databasing in 1 hour. I cannot do it in a month, not in an hour. What I'm going to try to do today is give you an idea how you can think about creating systems and how to think about databases. That there are some other things that the straightforward database usage. So what are the things that people require us to deliver? I assume we are like software engineers, system architects, and stuff like that, and the people asking are some managers, clients, and stuff like that. So they want speed, they want availability, reliability, scalability, etc. And what they don't understand, and what you need to make them understand, is the total cost of operation. Total cost of operation is a simple math. So all of you know how to add 5 numbers or 50 numbers. That's all you need to do to calculate the total cost of operation. What most of you don't do, and what none of the clients do, and what most of middle management do, is get an idea that they need to calculate total cost of operation for any type of production work. What is the total cost of operation? Anyone knows what the total cost of operation is? Oh. So the idea is to sum everything that you need to put in advance, that you're going to put as monthly operational business, and what you're going to put into servers, and what you're going to pay to add new features. So it's a cost of design of the system, it's a cost of development of the system, it's cost of maintenance of the system, it's cost of the servers. Or if you're renting them or buying them, etc. When you're looking at what we see normally, like a conventional setup, what everybody is thinking about, we have some sources, models, layers, like 50 layers or 5,000 layers or 1 million layers if you're a fancy, modern 2019 developer in a big company. And we have here what I say, here be dragons. Normally, where the data is stored, how the data is stored, how the system is monitored, is something no one thinks about. Usually you see the database as a black box, and you don't think about monitoring at all. These past few years, we have this DevOps, imaginary guys who are supposed to fix that. Yeah? that nobody knows who they are, how they do, where they learn, how they are doing that, how to learn, what the spec of their job is. Everything we don't know how to do, it's the DevOps guys. Yeah? I see some of the DevOps guys there. So why is this magic? Why so little energy put into understanding that magic and how to solve it? I know that our education is shitty. I know 100% in Serbia it's shitty. I know 100% in Bosnia is shitty. I know we have some foreigners here. Maybe you're lucky. I don't know. I doubt. Is there too much information and we're just too stupid to understand it? Maybe. I don't know. Is it too complex so we don't get it? So we need Microsoft and Google to make AI to understand it for us? Maybe. Not sexy? I don't know any girl that, go and do that. It's mostly us fat, ugly guys. Money not good? That is something a lot of people assume. That's a huge error. There is way more money in understanding data than doing anything else in IT. There is more money in understanding data than in machine learning, than in programming, than in what DBAs does, what DevOps do, what PHP developers do, Python, Ruby, whatever. So the money is actually superb. It's just too few people doing it, so you don't know how much they're earning. So what to do about it? What you need to think about doing to understand the problem, and for that not to be magic anymore, but to be understood. So understand the problem, yeah? It's kind of simple. You understand that you have a problem. You know the Alcoholic Anonymous, if anyone ever had an issue with that? I know in Bosnia it's not considered a problem, right? So they tell you first need to understand you have a problem. I'm Bogdan Kecman, I'm an alcoholic, that sort of stuff. So we need to understand we have a problem. We know shit about what our database is doing, how it's doing it, why it's doing it. We know shit about monitoring. We need to know that we have a problem. We need to know about the tools, not the hype. Now this is hype or that is hype, and we look at that. You need to spend time researching what tools are available for all the problems you have. And you will find weird stuff that do work for no money, way better than the expensive stuff that is advertised. Just a few days ago, I was explaining to my 6-year-old, if you see they are advertising the toys on the TV, it's shitty toys, that's why they need to advertise them. So you don't need those toys. You want the toys you like, irrelevant if they're on TV or not. Think outside the box and know the box. So it's very cool to say think outside of the box. Everybody is looking for programmers, system administrators, developers, architects, designers, everyone who thinks outside of the box. That's bullshit, okay? The point is you need to know the box. You need to know what is already available. You need to know the tools that you are using. You need to know how that tool will work. In order to step outside of the box and look at it differently and use some other tool, maybe. Just stepping outside of the box because it's cool to step outside of the box is the wrong thing to do. So know the box before you decide to step out of it. The problems that are there: availability and reliability. Even very small, insignificant sites get posted by some famous asshole who has like 2 million followers, and they crash. So even the small sites, insignificant application, need to have some type of reliability. It doesn't have to be fast for 2 million users, but it should not crash. Scalability. I mean, there are two very different approaches to scalability. Number one is you don't care about scalability until you have a problem with scalability. So you say, today I have 2 megabytes of data, and tomorrow I'm going to have 2 gigabytes, and that's about it, and I don't care. And I plan to sell my product in 6 months, and then hitni lopticu šumicu, let them worry about it. I'm going to sell my company, be rich, and that's it. And if I don't sell company, I'll close it anyhow because I have no idea how to monetize it, and I'm going to make another one that I will probably sell. It's okay, I don't like that approach. The other approach is you plan for success. You plan you're really going to have a lot of data, and you immediately plan how you're going to handle the data. Because data grows a lot, data grows fast. Gigabytes are nothing, terabytes are like everyday stuff, petabytes are here, zettabytes are there tomorrow. Companies, ridiculously relevant companies are handling petabytes of data. Right now, Sony, Hitachi, Toshiba, they're selling storages for the petabyte storages that are accessible to me, to you. So they're making petabyte storage, they need to drop the price so it is accessible to you. You can buy a petabyte storage, the minimal unit, for like 3,000 euros. Every developer can pay for that. Why? Because they are expecting we are all going to handle that much data in a very short amount of time. TC optimization is something, as I said, top management don't think, so they're not really relevant. They think about some other stuff, you know, girls, money, Bahamas, whatever. But the middle management, the low-level management, us in development, we need to think about this stuff. You can start with the junior developers fresh out of school that work for peanuts, work on shitty frameworks that are slow, but quickly to develop. So you are going to push your application fast, and it's going to be crappy, but it's going to be super cheap. And the operation of that application is going to be enormously expensive because servers are going to cost you arm and a leg to run that. Or you can get good developers and use a good framework that requires you to put a little more effort into your system, design a system a little bit better. You will pay a little bit more in advance, or much more, it depends. But the system will work better and will cost less. So depending on how much money you have at the start and how quickly you need to go public, who are you taking the money from, you need to optimize, you need to find the balance between the two. This is one example about knowing your tools. This here is like a super simplified top-down view of InnoDB storage engine. This here is the same stupidified top-down look at Oracle database. This is something every single one of you in this room needs to understand, and I can bet that 80% of you never saw these pictures. You not need to know that these pictures exist, you actually need to know what each of these boxes are, how they're connected between themselves, how they operate between themselves. And if you're going to use InnoDB, you really need to know why you're using InnoDB and not some other storage engine. Or another database system, for that matter. Maybe you don't need to use MySQL, maybe you want to use Postgre, or SQLite, or Mongo. The very simple MySQL layout. You have the clients. Well, you don't see it. We have the clients. We have the MySQL-D. This is MySQL-D. This is what everyone thinks is that this is the only thing that exists. These are the storage engines that most people don't understand. When you read the stories about MySQL versus Postgre, they are talking about MyISAM, and MyISAM this and MyISAM that, and Postgre is better because MyISAM can, but there are like a whole bunch of other storage engines there. And you need to know all of them, really. You need to know every single one of them and what they do and why they're good for you or not. You want high transactional throughput, you want InnoDB. You want super huge amount of write and fast primary key queries, you want MySQL cluster. MySQL cluster runs 99% of mobile traffic in the world. Every Ericsson and Alcatel and Nokia Siemens deployment, which includes, I think, at the moment, all 3 operators in Bosnia, for example. I think they didn't move to Huawei yet, or one of them did. They all run on MySQL cluster. Every single time you use your phone to do anything, it's recorded in MySQL cluster. So it can do a lot of things. You just need to know it exists for start. There are different ways to use tools, okay? So we all know how to use an SQL server, MySQL, PostgreSQL, Microsoft SQL, Oracle DB, DB2, or whatever other SQL server there is. You write an SQL query. But if you step back, read a little bit of documentation, you can see that there are some different stacks, for example, inside MySQL. I'm talking about MySQL because I know MySQL, I work for MySQL, so I can talk about MySQL, I cannot talk about Microsoft SQL. But similar things exist in MySQL, in Microsoft SQL too. So for example, if your application normally talks through SQL, it comes here to something called a parser. Then from parser, it goes to something called optimizer. Then from optimizer, it goes to something called executor. And then that executor talks to the storage engine. For example, in this case, InnoDB storage engine. You know your data, okay? Who knows here what optimizer does? Come on, guys, you're developers. This is an IT conference. When you write an SQL, you write some universal, using universal query language, okay? You're asking for some data. That data needs to be retrieved from the storage engine somehow. The way that data is going to be retrieved is decided by something called the optimizer. What tables the data are going to be collected from, how, in what order, what indexes are going to be used, how the indexes are going to be merged. All those decisions are done by optimizer. It is a very complex, highly buggy, incredibly stupid piece of code, especially in MySQL. Other database systems have way better optimizers than we do. In 0.14, it's much better than before, but still, Postgres is better, Microsoft is better, Oracle is better, DB2 is better. Anyhow, even the smartest optimizer in the world don't know your data. Need to go check the statistics, need to go query the data, need to understand the data before it makes the decision. You know your data. Or you're in the wrong business. Go lay tiles. You know, it's better hourly wage than programmers. They earn more. So what you can do is you can bypass all that and talk to the InnoDB directly. So you don't write SQL. You write like 100 lines of C code instead of SQL, but you get performance. Now, if you take that you're going to execute that query a billion times in a lifetime of application, you save a huge amount of money and resources. There is, for example, another alternative way to access data in MySQL. There is an HTTP plugin. It's 180 degrees different from InnoDB API that is like super fast, but you need to write a lot of code. Here, you don't even need a connector to connect to MySQL. You go to port 80, or 433, and you talk HTTP to it. And you just say, select in a bloody URL. And you get the data back in JSON. Or you have a REST interface, or you send a JSON query and you get the JSON back. It's slow. It's going to be slower than writing in SQL. But if you are writing something in React.js or JS whatever, and you don't want to drop down, have a connector, connect to SQL Server, and do all that, you just HTTP pull, and you have your data in your website. It works. It's slow, but it works. Now you can have some caching there and stuff to speed it up, but this is something you need to know exists. You maybe never use it in your life, but you need to know it exists if you are a MySQL user. If you're a Postgre user, you need to know all that type of stuff for Postgre, of course. This is an example what you get from like normal SQL and through InnoDB API. So we are talking like 7 times faster through InnoDB API than going through the SQL. This is like there is an InnoDB API. MySQL cluster is way more complicated. So there are a lot of ways to come to your data. Your data is physically here. These are all the layers you need to go through or you don't need to go through. The green is your app. So your app can go through, for example, if it's Java, can go through JPA, cluster JPA, JDBC, goes to MySQL, that converts it to SQL, use NDB API, and then talks to the data node. Or your application can directly talk NDB API and talk to data nodes. Difference is like 70 times in speed between this app and this app. It's also 70 times more code here. So now if you look, for example, in Ericsson, they in the single system have parts that goes through here and parts that goes through here. That thing that handles all the requests that your phone does every time you do anything talks directly through NDB API with the data nodes. The one that is managing nodes, managing tables, creating tables, billing, stuff like that, analytics, they're writing SQL. Not even SQL. SQL is like this one's here. This one here is this JPA, it's like ORM stuff. So it's even worse. But they don't care. I mean, you click, I want to report, and if report is generated in 6 hours, that's cool. So these are some VLR, HLR, user database. Those are just parts of the mobile deployment system that uses MySQL cluster. Also, what MySQL cluster can do is can be persistent Memcache. So we have a Memcache server that uses MySQL cluster as a backend. Now, if you're using Memcache, you know that Memcache replication and fragmentation don't work for shit. So if you need scalable Memcache, it doesn't work. It has a whole bunch of problems because the fragmentation is done on the client. If you have different clients on different machines, you will have issues. If you're using different technologies in different parts of applications, you will have issues. And of course, Memcache, when you restart it, doesn't exist anymore. So here, you can have as many Memcache servers as you want. They all have the same backend, so all of them have the same data. And it's persistent. This is the speed difference. The yellow one is just a ping, so we know what is the round trip for a single package. Memcache is around 184 milliseconds to get and set data on a single node. With NDB cluster, one node and two node cluster, it's like 370 milliseconds. There is no more graph after the two node cluster because 6 node, 8 node, 10 node, 12 node, 200 node, it's the same speed. The difference is by adding more, you get more storage, you get more write performance, etc. So it's a little bit slower than using only Memcache, but it's persistent storage. It's way faster than Redis. And it's like super simple Memcache APIs. Idiots can use it. This is accessing data through SQL versus NDB API. So you see here, this is logarithmic scale. So this here is 1 million TPUs. This here is 100 million TPUs. So, I mean, we're talking 70 to 100 times faster everything. And don't forget that this scales as much as you want. You need more write, you add more servers. It's super cheap. Hardware is cheap these days. Similar things with Postgre. There are compression in Postgre that many don't know exist. You speed a lot of things by turning on the compression because I/O is expensive, CPU is not. If you look at the load on your database server, it's mostly having problems with I/O. The CPU is not using it a lot. So if you turn on the compression, you increase a little bit usage on the CPU, but you're reading and writing less to the disk, so you need less I/O. Especially important if you're using virtual machines where I/O is like super expensive. Who here knows what a columnar database is? When you read a row from a database, in a normal database, like normal SQL, Oracle, Postgre, you need to read the whole row. Which, if we're talking about user database, which, you know, user ID, username, password, email, it's not a big deal. But if we're looking at some big analytic data where we have like 200 columns in a row, it's a big deal to read the whole row every time if we only need 1 or 2 columns. And that's why those all-up cubes and all those super cool analytic systems, when you give them SQL database as a backend, work like shit. They're slow, they're super slow, and sometimes they cannot finish in real time. Not in real time like now, in real time like in your lifetime. And that's why people came up with columnar databases. There, like in normal database, a single table is stored in a single unit. So it's a file with pages, or it's a file, or it's a segment in a bigger file, but basically you have a whole row stored in the same place. In InnoDB, for example, you have one file with pages, and in each page you have a number of rows. With columnar database, each column is saved in a separate storage unit. So file. It depends on the implementation. Some use row partitions, some use files, some whatever. But we're storing now columns and not tables or rows in a file system unit. So what you can do then is read only one column. So you don't care if your row is 300 columns or is like 5 megabytes wide. You read only the columns you need. The problem is there are no indexes. You're always reading all of them. But if you're doing all-up analysis, you don't care because you want all the data. So who cares about indexes? Anyhow, get stuff way faster. And for Postgre, it has some way to help you, for example, with that. First, you need to know that you can have columnar storage engine in PostgreSQL. That's like step number 1. It exists. In MySQL, it doesn't exist. There is a separate storage engine did by Maria Foundation. So MariaDB have a storage engine that is columnar. It's still in like pre-alpha stage, but exists. It will exist. It will continue to exist. Postgre have now advanced features, advanced ways to help you deal with this columnar system. So, and the other systems also. So it has CUDA support, for example. So you can use your GPU on your database server that doesn't do anything because it's a database server and not playing games. And you can use it to do some stuff. And it will accelerate some stuff, some sequential scans, some aggregate functions, and some other stuff. Now it will not always work good, and it will not always work great. And here we have some results of some different tests. This PDF is going to be available for download, so you can find the sources for all this and read it if you really care. But you can see that not all types of queries have the benefits of all this advanced stuff. This is like one super great thing because I don't understand it. For me, it's like super cool because I have no idea how this works. TakuDB is a fractal storage engine for MySQL, or it uses fractal indexes, or something like that. I really don't know. The graph was made by Mark Callahan. The guy was working for Google, Facebook, and now I think it's running his own consulting service. He was one of the designers of TakuDB engine. TakuDB have the ability to insert incredible amount of rows into a table. So the green line is rows per second in InnoDB. The blue line is inserts in TakuDB. As you see, InnoDB somewhere here goes to not working. So you are inserting some peanuts into a table because it's recalculating indexes every time and doing all sorts of stuff. And the blue graph is the magic. How the bloody hell they're putting 15 to 20,000 rows in a table at that amount of data, at 1 million, no, this is 1 billion rows? No idea. I spoke with Mark. He tried to explain this to me 3 times. I read all the white papers that exist on the subject. I'm not smart enough to understand, I'm sorry. Maybe some of you are. I mean, Google TakuDB, they published a whole bunch of stuff about how fractal indexes work, how the TakuDB work, how that works, what the story behind it is. I don't know, I finished university, I'm a manager. I'm of those that don't think. So this is like way over my head. But it's super interesting, and you need to know, and I use it. I know it exists, I tried it, I use it where I need it. It inserts huge amount of rows. Cool, works. Just like you need to know that archive storage system exists, that black hole storage system exists. You need to know what they're used for, how they're used for, and you decide to use them or not. Now, server monitoring and profiling. This is something that management is too stupid to understand. I'm sorry, I'm sure we have some managers here. And if you don't, you're an idiot, I'm sorry. You need to set up monitoring from before you're starting to design your system, okay? Like that is the first thing you need to do. Because if you don't have a proper monitoring of your system, you have no bloody idea what the hell is happening on the system. You just have guesses, and with guesses you can be so much wrong that you cannot imagine. You need to have monitoring from the day zero. Please understand that. You really need to monitor everything. Now, MySQL have this MySQL Enterprise Monitor, or Merlin, as was the code name was, which unfortunately is not open source, nor it's available for free users. But Oracle have one cool behavior, let's say. I don't know if you ever used any Oracle products. They don't have serial keys. There is no trial. There is no, here is an education license. You go to edelivery.oracle.com and you download anything that Oracle makes. It's a full version 100%. If you think you can use it, use it. If you don't, they have very bad lawyers. They can destroy you in a matter of days. So their policy is you can download any of their applications, any of their servers, anything they make, and you can try it out. You try it, you see if you want it, you don't want it, you like it, you don't like it. If you don't like it, you don't use it. If you like it, contact sales and discuss with them how you can use it. So you can download MySQL Enterprise Monitor from eDelivery, set it up and see what it does and if you like it or not. So you should do that today or tomorrow. It is the single best thing for MySQL. Example, you have a query that takes 0.01 second to execute. Can that query be a problem? Yes. If you think no, you're mistaken. Yes, it can. You have a new developer. He thinks he's a senior, but... And you have some PHP that's included from a zillion places in your application, and he puts there some super fast query that takes 0.01 second to execute, and everything stops. And your DBA is killing himself, hitting his head in a wall, trying to figure out what's going on. Looking at slow queries, he cannot find the problem. Looking at show process list, looking everywhere at profiling. Nothing is a problem, but nothing works. You start to Merlin. You look at the statistics. You sort, for example, queries by the total execution time of a query. And you see that there is a query that takes 0.01 second to execute. That is executed 50,000 times per second, and it's killing your database. It is impossible to find that query with any other tool at the moment for MySQL. So you can find the problems before they exist. You can even find the problem, so before your application stops, you will find that problem. Not to mention that all this machine learning, deep learning, and blah, 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 you have all embedded that into Merlin. So there are plugins that are looking at the behavior of your database and giving you warnings that you can have this type of problem, you can have that type of problem. We suggest you increase this parameter. We suggest you check this out. We think you should look at this, look at that. So it's a like super cool thing to have. You get it for free if you are MySQL Enterprise customer. MySQL sys schema is finally part of MySQL. It was an external project done by one of my colleagues. It's a set of views and store procedures to deal with MySQL performance schema, where MySQL is doing the internal profiling. So it gives you a lot of data about your system. It allows you to easily access a lot of data about your system. Check it out if you use MySQL, look at the documentation. PostgreBadger and Freen also do a lot of similar things for Postgre. There are Nagios and Zabbix monitor plugins for those that cannot afford to have Merlin. Don't do all the things that Merlin does, but do a lot of useful things. DB model optimization. We need to hurry up, we're running out of time. This is very important. If your DB modeling guy is normalizing and denormalizing in his head, fire him. Like, don't talk with him, just fire him. You need to optimize your database to at least third normal form and document that. Then, if you think you can speed things up by denormalizing it, and you can, usually, denormalize it and document that too. And document what you denormalized, why, who did it, for what reason, and what is exactly done. And in 6 months, when someone asks you why is this decision made, you have it. Okay, it is very important. If you just have the normalized database, it's a shitty database. If you have normalized database that is denormalized and you know why, it is maybe a good database. Queries can be tuned if you write them yourself. This, now you will read this in the PDF if you ever download it, but this is a query that takes between 3.5 to 5 seconds to execute. Optimized, this query optimized takes 1.5 seconds to execute. So that's 3-time optimization just by rewriting the query. This query takes 10 minutes to execute. It is a standard ORM-generated query. The same query takes 10 seconds to optimize, when it's optimized. It's still slow, but 10 minutes to 10 seconds, that's like 60 times. It's ugly, the query is still ugly, but it's manageable. You understand what it does better than the previous one, and it's 60 times faster. You could compare them. These are some sources where you can find the more information about what I was talking about today. And if you wanted to have some questions, if you use the application that is provided.
Thank you, Bogdan. We have time for a couple of questions. Yes, you made it on time. So the first question is, Amazon CTO said that SQL products are fastest growing service in the history of AWS. Why SQL is beating NoSQL, and what this means for the future of data?
Okay, well, I said many times, you can care about your data or you don't care about your data. If you're storing every single move on your website, if you lose last 5 days of data, you don't care because you have like 2 years before that, you'll have 2 years in front. If you lost 5 days, who cares? So you can store it in Mongo. If you care about your data, you want some transactional storage engine that will take care of your data. Now, I wouldn't care much about what anyone from Amazon say because they are guys working on the minimal profit margin, on hype, and are really not doing what is good for the IT community, but what is good for themselves. And the major reason why the RDS and MySQL there and other SQL offers from Amazon are available, are like growing like crazy, is there more and more idiots are joining the IT community, and they don't know how to set up the Postgre cluster on bare metal or MySQL high availability system on bare metal, and they pay someone else to do it for them. And the RDS is like 3 clicks and you have Postgre cluster working. So that's why.
And one more for the end. What is your opinion about ORMs?
Why me? Why again? Okay, I had a huge fight on the stage a couple of years ago because I hate ORMs. Okay, I think you're not very smart if you're using ORMs. But I've kind of changed my mind in the past 3 years because ORMs are getting bloody good. It's crazy. I mean, I still hate my customers when they use ORMs because they come with those queries that execute for 10 minutes and are impossible to read. But really today, ORMs are getting good, getting way better than they used to. For example, Falcon and the whole thing about Falcon, it's like it's generating queries that are good. So it's still a matter of TCO. You will have faster deployment with ORM. You will not have as good and as optimized queries, but most ORMs today will allow you to use both. So when you have a critical part, you just write an SQL yourself. When you don't have a critical part, you let ORM do the magic. So I'm not so like 100% against it as I used to be.
Okay. Thank you, Bogdan, once more.
Thank you.